Today I'm finally going to look at this gigantic desktop from Orion Multisystems. This is one of the very interesting things I've picked up over the years, which is ultimately useless, but you know, it was cool. And I'd like to keep it because it is rather rare. I mean, it's kind of beat up, but it's rather rare, and it's a very unique system, and it was a very expensive system, like 20 grand or something like that originally. I mean, first of all, look at the size of it. This is a regular keyboard. So how many desktops do you know that are way bigger than a keyboard? Yeah, the reason for this being so large is that it is 12 computers in one. These are clustered workstations. There's also a desktop version with 96 computers in it. And I say computers, not cores, because this is literally individual computers on a giant board with their own independent memory, hard drive, CPU, and they're all linked with an internal Ethernet network. So if we power it on, you can hear the giant 80mm fans kick on. And let me just adjust the camera so we can see. But as we power it on, it'll load Grub and a whole bunch of other stuff. It's running Fedora, and it's a custom build of it because it will eventually initiate a boot up sequence for all the other systems, and they all work on a single task. You can there's a master system, the first one, and you would give it a task and it will initiate, it'll split it between all the other ones for compute purposes. So in this particular case, I believe this one was from, I got a long time ago, I think I have a screenshot somewhere, but it was from a company or government facility that does chemical and gene research, I believe. I can't remember. But yeah, so they were using it for like chemical modeling and stuff like that. And this uses the Transmeta chips, which are low power x86 clones. These particular ones run at 1 gigahertz, and they're they're fairly good for the time. They're not fantastic. They're like a mobile Pentium 4, and there's 12 of them, so it has a decent amount of compute power. Although it's not like it's like a modern system which would easily just destroy it. Which is one of the reasons why I want to get rid of this thing, because it's so large. And the distributed nature of it means I can't even like screw around with it and run like a benchmark on 12 cores or anything, because they're individual computers. You have to have a specific task that you can distribute using their software. So it's not something you can really play around with, and it's all Linux based, and I hate Linux. So, it's going to end up in the recycling bin today, but it is a very cool system, and like I said, I'd like to be able to keep it, but it's something that's just so niche that I could never use it for anything, and it's too beat up to keep in a way that, it's like a museum piece. I didn't pay too much for it. It was like 60 or 70 bucks if I recall, and for a system that's this unique, I thought that was totally worth it. In fact, it's trying to connect to the OrionMultisystems.com time server, and Orion Multi went out of business soon after these were released because, well, one, it's such a niche product that they're not selling a lot of them. They have a high cost, so schools and stuff didn't want to buy them. And two, they only were 32-bit chips, and they didn't have a 64-bit planned. Well, they wanted to, but they never got around to it. And because they use cloned chips, people weren't as eager to use them because they weren't a standard Intel or AMD chip. They're a bit hesitant about these like low-power Transmeta chips. So I think all of that kind of combined to just really kill this thing, because in compute applications like this where the system is simply designed to crunch numbers, a lot of the times they really do need a 64-bit platform just due to the nature of what they're working on. So the system's still booting up. It takes a while to check for the time server and all that stuff. But eventually it's going to load the Orion node stuff, which will then boot the other cores. And currently it's pulling 40 watts. And we'll see the power skyrocket to like 200 or so as the other computers themselves boot up on top of the existing one. And there's a huge framework connecting them all. They've got, like I said, an entire Ethernet network built into the board. And there's giant Broadcom controllers, which we'll get into. And yeah, so the whole network is how the system communicates. So I'm going to lower the camera, and we're going to watch the other systems boot up. Oh, there we go. So now all the other drives, the top one I believe is just a status indicator, and the bottom LED is hard drive activity and status. I don't know the details of it, but you can see the master system is operating, and all the other ones are in standby, and it's currently pulling 191 watts. Now it's asking for a login. I don't have the login, and it's running Orion Multi-Systems Incorporated Linux Release 2.0. It's kernel 2.66, and that's about as far as we can get. I have looked through the drives, and there was information that led me to that. I think it was the government site that owned this. So that's the only reason why I know this information. See, this one's trying to do something. And yeah, so it's interesting, but we're going to take it apart. So let's get to it. On the rather beat up front, we have a power switch. When power is applied, it goes into standby mode, and it's pulling like 30 watts or something in it. I believe it's running the Ethernet network and some other stuff. And it's not until you hit power that it kicks on the main system. There's also a hidden tray loading slimline optical drive, and we've got a USB port over here. And if we pop the front off, because I'm missing the screws for this, we can just see the big array of LEDs to indicate the status of all the nodes. Around back we have what appears to be a standard 1U power supply. There's also 3 Ethernet ports at the back. Not really sure what the difference is between them all. They might just be all the same thing. And we've got a serial PS2 port, that's a keyboard port, and a DVI connector for video, and some SCSI connectors, which is a little odd. And if you look carefully, you can see how the 2 screws hold this weird little divider thing on. And at first you're like, well, what is the purpose of all that? Why couldn't they just cut out a little thing here? Like just make the cutout so it fits. And I think the reason why it's a little weird is because I think they make a version of this without the SCSI port, so they just make a wider plate that covers this, and it just covers up the blank spaces. I think that's what the deal is. An inside BIOS. I've never actually heard of this company. Most BIOSes on a PC are either AMI, American Megatrends, or Phoenix. So I don't know who these guys are. The BIOS is a little lame. It's got like a menu system and stuff. It's basic, but it tries to look fancy. So yeah, it's not even worth showing, to be honest. It's just a BIOS, really. There's nothing specific to this system in it, from what I can tell. Also, I think it may only control the one system. I'm not sure. I don't know if the BIOS changes affect every node or what. As you can see, I wasn't kidding about it being a whole bunch of individual computers. You can see how each one has memory and a hard drive, and it's all split up, and there's also this whole network of, well, I mean, it's a whole, one giant board, but there's a Broadcom controller with like a little Ethernet cable and stuff like that. And there's also an array of, I think they're 80mm fans, 4 of them, but we'll get into that in a bit. So you can see just the massive size of this board. This is one PCB that runs from here to here and there to there. That is one giant board, and it's a fairly thick board, probably 10 layers would be my guess. There's also an even thicker board on the back plane. all of these individual hard drives are all Fujitsu 80 gig, and they're all parallel ATA, and you can see that they all use the same mounting system. They screw in on one side and just slide into these pins on the other side, and yeah, I just yanked them all out. Now this whole panel covers the motherboard, and I think I got enough screws out of it that it should just come out. Okay, these DIMM slots are in the way. I have to open up or close the DIMM latches. Kind of a stupid design. Alright, so this is just a big sheet of aluminum. Kind of annoying, they had a little wire tie on one corner of it, but you can see it's just a nice piece of aluminum. It's rather sharp. Here we are. The giant sea of surface mount parts. Now, each one of these heat sinks pops right off, and it's got the Transmeta Efficient chip, 1 gigahertz, and we can just start popping these guys off since they're not really doing any good. And it looks like this is probably just a system management hub, like a North Bridge or South Bridge. There's also an Intel chip here that might be an Ethernet controller, because these are connected all via Ethernet internally, and they're actually labeled node 0, node 1, node 3, 5, blah 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 blah. There's a couple mod wires. Try and get a better look at those in a second. And we've also got the 2.5 inch parallel ATA interface, and each one of them has a little surface mount connector here. Not really sure what that's doing, possibly for testing, but let's try and get this motherboard out. I decided to give this thing another shot before it really comes apart, so I put some memory back in to the first node, and I burnt a copy of MemTest onto a CD, since the BIOS on this does not support USB booting except from a USB CD-ROM drive. So I might be able to get that to work with my external drive, which fakes being a USB optical drive. But I did manage to get it to actually boot into MemTest. As you can see, it has 1 gig of memory, and it's rated it at 569 megabytes a second, which is embarrassing. That is really low memory bandwidth. It's also saying it's a 1200 megahertz clock. As far as I know, these are supposed to be 1 gigahertz, but who knows? And I probably shouldn't be running this without a heatsink. In fact, oh yeah, that chip's nice and toasty. Well, it doesn't look like it likes Windows too much. I think Windows 8 needs a more modern CPU. I think it needs like SSE 2 or 3 on the CPU, because yeah, I get this lovely logo and then that. So yeah, oh well, I thought it would just be fun. I'm not going to bother installing an older copy of Windows on it. This is one of the little heatsink modules. As you can see, it's just a basic design with little aluminum fins, anodized, and they were quite dirty when I got them, so I washed it off, and it's just got like a thermal pad on it, and they clip on using this little side piece of plastic. It's one of the 80mm fans from Delta. They're 3 cable, so they don't have PWM control, and for some reason this one has splices going to another connector. No idea why. Maybe it was something to do with the routing. And they're 80mm, and they make a fair amount of noise, but not too much noise. I suspect most of the noise is coming from the power supply. Those little 1U power supplies make quite a bit. But there's 4 of these guys, and I think they're fairly quiet. I seem to be making some progress on getting this thing out after taking out all the fans and taking off the front panel, which is just a bunch of screws. It's just an aluminum plate, which we saw earlier. This board seems to be loose now, as does the whole module it's sitting on, so I think we can just disconnect this from the giant connector at the back. Oh wait, hang on, there's a ribbon cable, and we'll might as well disconnect this Ethernet cable too, which is extremely short. And there's a power connector here. That is one big connector at the back. I don't know if it has a latch or if it's just... Okay, there we go. Alright. One board. The back piece looks like it's pretty straightforward to take off. It looks like it's just a bunch of screws along the back, and it's got this big guide pin. So you line the motherboard up with it. This is a very thick board at the back. I'll take a closer look at it when I get it out, but it looks like it's probably, geez, it's probably got to be like 20 layer or something like that. Oh, I think I'm going to have to go around back and disconnect all the little thumb screw posts and stuff for the connectors. A whole bunch of screws later, I got the big chassis off. You can see the flat flex cable going to the optical drive and the power supply up here. And I managed to get that backplane board out. It used a whole bunch of screws, and it took a little while, but it eventually came out. Let's get through the odds and ends before we get to the good stuff, the big boards. I think I mentioned before, these are just Fujitsu 80 gig. They're all the same. Parallel ATA. The optical drive is a parallel ATA, surprisingly a DVD rewritable drive. I didn't expect that. I might hang on to this because it's a parallel ATA drive. I don't really have any of these, so might as well keep one just in case I need it. It uses this custom flex cable that connects with this funky 2-pin power connector to give it 5 volts. Yeah, there's a little adapter on the power supply, which we'll get to. And the front panel is just this little clasp thing. And the 2 boards that are attached to it are pretty simple. There's one here that's just a USB connector. And one here that is just the power switch. And it's kind of a cool switch. I like the button they use. It says Cirex, Cirexx. Never heard of them. And you can see that they actually have a provision to put the connector in a different orientation. All the DIMMs are 1 gig DDR1. Nothing special. They're ECC though. On to the backplane board. Now this is a very, very thick PCB. This probably has to be like 12 plus layers or something crazy. And on it we've got all the rear panel connectors. Obviously there's some kind of BGA package here. This is the huge interconnect to the motherboard. We've got all these Ethernet ports. Now what's cool about these Ethernet ports is that they are, well, these ones may not, oh hang on. These are actually press fit. And this is very common on well, a lot of networking gear. And I mean, like, I've seen it a lot on like Cisco stuff. And yeah, the whole idea is that these just physically press into the socket, or the PCB holes, and it's actually a very reliable connection. It also allows it to flex just a little bit in case of, you know, like thermal stress, that kind of stuff. So yeah, they work well. On this side we've got probably termination and stuff for the SCSI on this side. And we've got the fan headers and just odds and ends. This heatsink is actually covering up a multi-chip ATI Radeon Mobility 9000. And it's actually a very interesting package. As you can see, it's a multi-chip module. It's one BGA package with other BGA packages on top of it. And yeah, it's got this kind of cool cross heatsink in it. Probably try and take that off. It just seems kind of cool. This is actually made by Molex, and it's the GBX like backplane connector series. I couldn't find an exact one, but they're approximately $50 a piece. And you can see it's got a huge metal guide pin, and we've got power on this side. And these are probably ground, the ones that contact first, and you have the little smaller posts and terminals inside that give you the data connections. And these things are, you know, like 6 amps per pin on the power side, and they've got high speed, I think it's like 6 gigabit or whatever on the data transfer side. I don't think they're really spending that much information, although the video card probably uses a fair amount despite it being a kind of slow card. And we've got some DC to DC converter stuff down here. And this is the input from the power supply. It's a Molex power connector, but it's a smaller one. It's not a standard PC one. And this is the same kind of connector that goes off to the DVD-ROM drive or DVD burner, but it's not being used. So I guess it had the facility to just plug power in here and run the cable out to it. Instead, as we'll see, the power supply has a splitter on it, so that's how they're getting power to it. But yeah, pretty interesting board. Like I said, very thick, huge board, and yeah, nice high-speed stuff on it. On to the motherboard. This is one of the most enormous boards I've ever witnessed in a part. This thing is approximately 20 by 16 inches. For reference, that's a computer motherboard. Yeah. So, this board is pushing the limits of how big an actual board can be in terms of panel size, because they don't make PCB panels gigantic. They make them a certain size, and you need a certain bit of extra around the edge. So it's up there. So what we're going to do is we're going to take a look at one of the computers on this thing, and we'll look at the couple little oddball things that are on the board. But for the most part, the 12 modules are identical on the board. So we'll look at one, and it's the same for all 12. The only part that's different is that back section. So this is one of the modules. I call them modules. I mean, it's they're clearly very separate systems on this board. So we've got the 1 gigahertz Transmeta Efficient chip. These I've kind of mentioned them in the past, but Transmeta makes or used to make x86 compatible chips, but they weren't actually really x86 compatible. They were like they operated on like 128 or 256 bit instructions, and had special software that would like in real time translate normal x86 code into these massive long words that it would use to operate on. And they found that this was more efficient. These were quite low power, like 3 watts. So that's why they use these in this thing, and they're only 32-bit, unfortunately. They also have an integrated memory controller similar to, like an AMD Opteron. We have an ALI chip. This must be the platform controller hub, or like the North Bridge, South Bridge combo. I don't know. Couldn't find any information on it. It says M1563M. Don't know. Like I said, it's probably controlling going to the peripherals, that kind of stuff. We also have an Intel chip here. This is the RC82545GM. It's just an Ethernet controller, nothing special. We've got the parallel ATA connector, the single strips of DDR memory. There's one per module. And there's also a little bit of flash here, most likely the BIOS or maybe some special boot data. There's also some on the bottom, so maybe they needed a lot of it. As far as I know, there's no boot image, so I'm not really sure. There's also a little header connector here that's plugged off for some reason, probably for testing purposes. There are little flat flex connectors here. No idea what they're for. Nothing on this board is really labeled, so it's not like it says, test header or anything. We've got a Xilinx XCR3064XL, which is just a CPLD. And that's about it in these sections. Everything else is just DC to DC converter stuff for the most part. And you can see that there's this big network of baud wires running through to each module. And they're all coming from one pin on the CPLD. And my guess would be they made a mistake when they built this, and maybe this is to initialize them. There might be... I'm guessing the CPLDs are controlling like the power to the individual modules, like they're simulating starting them and stopping them. So, I mean, the fact that it goes from like module to module to module, I don't know. I think it might have just been a goof, and they the actual modules can't start up or something, or they need like a synchronization signal between them all, because this wire, which is they did a good job. It's actually like lightly glued down, and it's very properly done. They obviously did this on a nice jig and ran the wiring. But yeah, it's funny that it goes from CPLD to CPLD, CPU, go on and on and on. So yeah, it must either be a synchronization pulse or like a clock signal, or it has something to do with the the startup routine. Like it could be something as simple as it just takes this wire high or low, and that's what sends the signal to start up the CPLDs, which in turn start up the CPU. So I'm not sure, but yeah. So that covers one module, and there's a little thing that says this is node 11. Yeah, they're all the same except for node 0 over here, which we'll take a look at. Here we are at node 0. This is the main one. This is supposedly the one that you're controlling when you hook up a mouse and keyboard. And the only difference that I can find is that this one has this SMSC LPC47N252 controller, which is an advanced notebook I/O controller. Basically what it's doing is it's giving you a keyboard interface, parallel interface, serial, that kind of stuff. So I think that's how it's just getting a lot of the I/O ports that it's missing. This larger chip next door, the ALI chip we looked at earlier, is probably providing the stuff like the IDE interface, but it's not providing stuff like a serial port. So they add this one chip to this one module to give it the necessary stuff so that you can use a PS2 keyboard and stuff. And you can see that there's still a baud wire running by. And yeah, like I said, it snakes through the entire board. Now we're at the back of the board. The big interconnect is over here. This large chip is a Broadcom BCM 5692, which is a 12-port gigabit Ethernet switch. And that is how all these modules are connected to each other. Obviously they have something else providing these extra ports, but there you go. That's how it's an internal to the board Ethernet switch, which is kind of cool. Anyway, we've got another Ethernet controller and stuff here. They're scattered around everywhere. It's probably providing this port, which is what connected up to the back plane. There's a header connector here with a little mounting screw, which is kind of bent. I don't know if I did that or not. But yeah, so this header connector is possibly what gives you SCSI, because I can't find a SCSI controller on this board. So unless they're doing it in a Xilinx CPLD or whatever, because there's another one over on the other side, which we'll get to, I don't know how they're getting a SCSI connector. So, well, it could be that it's not a SCSI connector, although I'm fairly certain I saw it in the BIOS that it mentioned SCSI. So it's possible that you need a module here to really enable it or something. Not 100% sure. There's a connector here for USB, and it goes to the front panel. And we've just got various power supply stuff. Moving along towards the big interconnect, there's some small BGA chip here. I have no idea what that is. I looked it up. None of the numbers came up. I don't even know what company logo that is. It may be some custom thing that they did. There's a spot for a fuse here. It was in it. I popped it out earlier. More DC to DC converter looking stuff. And you got your little Orion Galaxy logo or sticker with the MAC address. This is the board side of the interconnect. As you can see, the really high density data connection, and then you got the big power connections, and you've also got the little receptacle for the guide pin. Tucked right behind the connector is this strange little gold topped package. You can see there's actually a lot of connections to it. I thought it was a clock oscillator at first. There's also a teeny tiny baud wire right here, but it says ICS on it. And let me see if I can get this little sticker off. Yeah, I'm gonna have to pause. It's really stuck on there. Well, that's certainly strange. There's nothing on it. It is actually sitting next to a real clock oscillator, but this chip, I have no idea. I'm gonna have to Google around these numbers and see if I can find any information on this thing. Because yeah, it just has nothing. I can heat it up and pop the top off, and we can take a look. But it's obviously some kind of digital circuitry. There's also a little CR232 or 2032 battery here, and you got some like odds and ends, probably just for buffering the signals through the high-speed connector. Alright, it took a little while, but I did eventually get an answer. It is a phased lock loop. The particular one is made by Integrated Circuit Systems, And there's a whole bunch of different models. I didn't find one of the exact one, but yeah, basically you can output various frequencies. It's generally used in gigabit Ethernet, no surprises there. So yeah, it's basically just outputting various clock frequencies to keep everything running, and it's most likely driving it may be a special interface that's going over the connector, so it's possible it's got something to do with that. They may not actually be using it for gigabit Ethernet, although it is designed all the way up to they make ones that go all the way up to 12 gigabit Ethernet, which is crazy. They use a 20 to 30 megahertz clock and output 125 to 187 megahertz. I managed to find a similar model on DigiKey, and it comes in at $50. The last section of the board is mostly blank. They didn't populate this. It looks like there's a space for one of those Broadcom chips, I guess. I don't know what else they'd be putting there. And the power supply circuitry to go with it. There's a Xilinx chip here, probably another CPLD, who knows what that's doing. And just, yeah, some either test headers or JTAG, who knows. The back of the board is just a sea of decoupling. And that's about it. There's some flash devices, and there's also a bunch of baud wires in this one little section. Doesn't seem to be repeated on the other module, so there must be some defect or something on this one module. No surprises that the only module with the mod on it is number 0, so obviously it has something to do with something specific to the one that you're controlling. But yeah, that's some fine work actually, but yeah, lots of mods on something very expensive. Very disappointing. Revision E3, and they still have all these mod wires on it? Power supply is just a 300 watt 1U unit from Sparkle Power, who, again, despite their name, actually make decent power supplies. We have this oddball set of connectors. Like I said, it's a smaller connector that looks like an ATX power connector, but it's not. We have a normal Molex power connector, but it's not used, and it just adapts with this little connector here to this little 2-pin deal where it's powering the optical drive. Very simple and completely useless. Inside we have a typical 1U power supply, very, very compact, but very, very nicely made. You can see they tape everything, they goop everything down. They're using, can't see which brand caps they are, but you can assume they are quite good because Sparkle Power does actually make half decent power supplies, although they tend to be loud. There's two 40mm fans in this thing. It does make quite a bit of noise, but in a server environment, which obviously a 1U power supply is designed to go into, it's not really an issue since server rooms are always loud. I like the little transistor, or maybe, what is that? It looks like a transistor standing up on its own little teeny tiny heatsink on this digital board. After many screws, we're finally at the end, and you know, it was a very interesting board. I mean, obviously it was like, you know, money is no object when building this thing, but and it's so rare that I really did want to keep it, but it's huge, so it's like, nah, it was kind of beat up, so it's like, who am I even going to give it to? You know, if it was in good shape, I would have given it to like someone working on like a computer museum or something if they wanted to come get it. Even if they couldn't do anything with it, it's just an interesting piece of kind of history, because like, now all of our chips are multi-core, like, you know, have quad-core systems and 8-core systems, blah, 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 blah. And you kind of forget the fact that, like, yeah, back then, this was like a way to really speed up your computer by just having more computers. Instead of having more cores, it was more computers. So this is kind of a unique architecture where yeah, you're actually working with a whole cluster of computers, although it's on one board. So, yeah, and it was, you know, so expensive. It was like 20 grand plus. It feels like a shame to scrap it, but unfortunately, that's where it has to go.